Hello folks, my name is Jamie Moles from ExtraHop, and today I'm going to be talking to you about detecting ransomware with network detection and response. So, traditional ransomware detection in the past has often been done on the endpoint using EDR, but a lot of the ransomware operators nowadays have changed their tactics and made it harder for endpoint solutions to detect them, which means that if you're monitoring the network side of things, and remember, the network never lies, you're able to see things happening that those guys can't hide from. Ransomware operators have a number of techniques that they use that show up like big red flags on a network that allow us to catch them. I'm going to draw out a typical ransomware attack and show you the key points that you can use, or we can use as an NDR vendor, to catch them and help you get them out of your networks early. So let's start right at the beginning. When a threat actor gets into your network, very typically by an email link or something like that, they establish a connection, an initial foothold on a workstation. We're going to call this workstation the Beachhead, BH. A user has typically clicked on a link in an email and it's downloaded malware onto this machine, which your endpoint detection and response tool might detect, it might not do. But if it doesn't and you're having to rely on the network, what stages does the threat actor go through after the initial intrusion that allows us as an NDR vendor to catch them? Well, the very first thing they're going to do, and I'm going to draw a few boxes here, is they establish a connection to the outside world using command and control, or C2. And that goes out via the internet to a server that they control, which gives them a footprint and an access into your network so they can start exploring. And remember, they don't know your network. They don't know how it's been set up, so they have to learn everything when they get in there. But they have a number of techniques and exploits available to them to allow them to do this in a fairly streamlined process. Now, a C2 connection is a communication from this Beachhead machine out to a server on the internet. So it's a communication connection. It's going across the network. It's something that we as NDR vendors can see. Now, C2 connections often go across TCP. They often go across port 80, which is the standard web port, which also known as HTTP. Why do they do that? Because that hides inside browser traffic that's going across your network, so it's disguised. If they're smarter, they will do it on port 443, which is HTTP/S, which is encrypted web traffic. Either way, it's a communication that's going out through your firewall and is designed to hide within your ordinary traffic. And this can be very tricky to find. Unless, like good NDR vendors like ExtraHop, you have been monitoring what this workstation does day in, day out, and you know what it normally communicates with, and you see these connections go out to somewhere unusual, shall we say North Korea or China, and this workstation doesn't normally do that. So the machine learning elements of our detection system will say, this is unusual for this machine. We should probably pay attention to it. Now, C2 is not the only opportunity that we have to catch the bad guys. This connection allows the threat actor on the outside to send commands into this machine and say, start exploring the network. Tell me about the environment you're in. Allow me to discover accounts on this machine. So they might try and find administrator accounts. They might try and find information about more important systems on the network, like the domain controller. And the reason why the domain controller server matters is because that's where all of the critical accounts and critical services run on the network. And if they can compromise the domain controller, they can get access to anything and everything on your network. So let's assume that for our argument's sake, they've established a C2 connection and it's managed to sneak through the network undetected. These things happen. What are they going to do next? Well, they've compromised accounts on the Beachhead machine. They've identified local admin accounts. They've used local commands to identify where the domain controller address is and what its IP address is. In the past, threat actors would typically use network and port scanning tools to scan the network to try and find things like the domain controller. But these were very, very noisy and were very easily detected by NDR tools and IDS tools. Nation-state threat actors devised a number of, or discovered a number of ways to actually find this information out by running local commands, and now all the ransomware gangs do the same. So actually the reconnaissance part of discovery doesn't happen on the network anymore. So we've lost the opportunity to catch the bad guys in the recon part of their operations. So initial communications out C2, that's an opportunity to catch the bad guys. Reconnaissance has gone away. What's the next opportunity we have to catch them? Well, I'm on my Beachhead server, but I want to get over to my domain controller, my DC. So I'm going to have to move across the network from the Beachhead server. We're going to just, let's say this is our LAN. And I'm going to go from the Beachhead server across the LAN down onto the domain controller. We call this lateral movement. And lateral movement, which is literally the moving laterally from one machine to the next, is now our next opportunity to catch the threat actors. However, there's a problem. For many, many years now, security operators and certainly compliance standards like PCI DSS, etc., have mandated that data going across networks should be encrypted for security purposes. Makes sense, doesn't it? If I'm sending payment card information from one machine to the next, you wouldn't want me sitting on the network sniffing the traffic and catching your credit card data. So nowadays, the data that goes across these networks is encrypted as a default, including the information that happens inside lateral movement. Most lateral movement that happens on networks nowadays goes across a Microsoft protocol, which we call MSRPC, Microsoft Remote Procedure Call. And this is encrypted as a default. And very, very typically, the threat actor will send a piece of malware from the Beachhead server across to the domain controller, very often what we call a beacon, very commonly used by tools like Cobalt Strike, which is a C2 framework that's very, very popular. And you typically cannot see this happening because it's going across an encrypted tunnel. It's invisible to most people looking at network traffic, unless you're using ExtraHop RevealX. RevealX has a capability built into it that we call domain controller assisted decryption. Simply what this means is this protocol MSRPC is encrypted, but the domain controller holds the keys to decrypt it. So RevealX logs into the domain controller and asks it for the keys, which then allows us to see what's happening inside the lateral movement. We can see the malware being sent from the Beachhead server to the domain controller. And we're the only network detection and response vendor that has this particular capability. We take what is an ordinarily very, very opaque set of traffic going across your network, and we open it up, but using your own keys. So it's legitimate. We're not breaking things in any way that cannot be done. So this means that we've now gone from having one initial opportunity to catch the threat actors, the command and control, the C2. Remember, we can't use reconnaissance anymore because they don't really do that on the network side of things. To the next part, which is the lateral movement from the beachhead to the domain controller. Lateral movement being the second opportunity to catch the threat actors. And both of these opportunities often happen very, very early on in an attack or a breach. Might even be within the first hour of a breach. Now, if I can catch the bad guys on either of these stages, C2 or lateral movement, and I tell you about it, and you pay attention to me because I've said this is happening and you need to deal with it, then you have a very strong opportunity, if you can get in there quickly, to get rid of the beacon that has landed on your domain controller, kill the C2 connection that's going out to the threat actor, and at that point, he's dead in the water. He can't do any more on your systems. But let's say, hypothetically, that you haven't seen this, or for some reason, you've not been in a position to pay attention when I've sent you an alert to tell you this is happening. What does the threat actor typically do next? Well, he's going to be on your domain controller looking for account information, looking for services, and very often exploring to find where your data is. Most data nowadays is stored on a file server. There's another server there, and let's extend our network out there to include our file server. And the domain controller contains all the information about where these files are, who has access rights to them, and it contains all the accounts and the keys or passwords or tokens, whichever is required to access these files. And your threat actor is then going to do another piece of lateral movement. So here, a third opportunity to catch him. He's going to move laterally from the domain controller down onto the file server. So on the network, we have had 3 opportunities to catch the bad guy. We've had the opportunity to catch him at the command and control stage. We've had the chance to catch him at the initial lateral movement stage to the domain controller. And then we have a third lateral movement from the domain controller to the file server where we can catch him as well. Now, interestingly enough, a lot of the time the threat actors don't just use tools like Cobalt Strike, which is useful for sending commands to these systems, but sometimes they will also actually download remote management tools. And very often these remote management tools are ordinary, standard out-of-the-box tools that we might use. They might use Microsoft's RDP protocol, remote desktop protocol. They might also go online and download other tools like AnyDesk. RDP and or Microsoft Terminal Server Client is the clients often used to use RDP, and AnyDesk have an advantage in that they don't just have a text window open to send commands. They now have actually a display on the screen as if they were sitting at the computer with the screen, the mouse, and the keyboard. So they can actually interact directly with the computer and interact with the Windows operating system as if they were an operator on that machine. So very often, the download of these tools from the internet, which is how they get them onto the systems, is a 4th opportunity to catch them. And AnyDesk in particular has become very, very popular nowadays for these particular operations, used by Scattered Spider and a number of the other threat actors. At this point, they've got their hands on the computer itself. They can go through the files, choose what they want of interest of the files, and then the next operation that they perform is exfiltration. This is where they send the files out to an external server on the internet, and a popular one that they like to use nowadays is mega.nz, and they will often send that out using protocols like rclone. And this is another opportunity to catch the threat actors. So we had an opportunity to catch them with C2. We had an opportunity to catch them with initial lateral movement. We had another lateral movement opportunity when they moved from the domain controller to the file server. We had an opportunity to catch them when they downloaded AnyDesk and installed it on these machines. And now they are sending data out from the file server using the rclone protocol to mega.nz. Another opportunity to catch the threat actor. So, I mean, this is a relatively short incident. This is very, very typical of the threat actors that we see today, and it can happen very, very quickly. This kind of breach typically happens in a very short number of hours. In fact, often the longest part of this incident is them spending time in the file server selecting what data to exfiltrate and steal. Why are they stealing the data? When I'm talking about a ransomware scenario, don't they just encrypt it and insist you pay up? Well, because the threat actors have had to change their tactics and techniques, because actually a lot of organizations have got very, very good at restoring stolen encrypted data from backups. And if you can just restore what I've encrypted, then I'm not going to get any money out of you. However, if I steal it and send it out to somewhere on the internet, I can also say to you, well, if you're not going to pay me to decrypt, perhaps you will pay me to not leak your data on the internet. Because, of course, it's huge reputational damage if your PII or the PII of your customers gets exposed on the internet. Plus, if you're the kind of organization who is regulated by a government regulator of sorts, you probably have mandatory reporting requirements if you're breached. And you would have to report this incident. And indeed, the ransomware threat operators nowadays are using this as an additional way to leverage you. They say, well, if you don't pay up, we're going to tell the compliance and the government organizations that you report to that we have breached you, and you haven't told them, which is often going to lead to large fines. So, to summarize, this is a very, very typical kind of ransomware operation that happens nowadays. This whole thing can happen in less than a day, although sometimes it might take longer depending on the size of the organization. And from the network, we have many, many opportunities to catch the threat actor. But what's our overall objective? Do I want to catch the threat actor when he's sending files out via rclone to mega.nz? Clearly not. It's game over at that point. He's already got access to my data. And after he's sent the files out, actually, there's another thing they do, of course, which is they encrypt the data on the file server, locking it out so you can't access it yourself, which then, of course, brings issues related to the business. Do we want to catch them here? Nope, that's too late as well. Do we want to catch them when they're downloading AnyDesk or other tools like that onto the system? Well, it's before they encrypt and before they send things out, so actually this wouldn't be the worst place to catch them. But in reality, if we can catch them right here at the start, and I'm going to put a number 1 here, because this is the first and probably the best opportunity to catch them. If we can catch them when they do the C2, that would be amazing. If we can catch them when they do the lateral movement, that's going to be a number 2. That would be the second best chance to catch them. But in reality, command and control frameworks can often be quite tricky to detect, whereas lateral movement, especially if, like us at ExtraHop, you are decrypting these protocols, which are encrypted with standard settings and standard keys, whereas the C2 could be encrypted with keys that you don't have access to. This becomes your best opportunity to catch threat actors who are trying to extort you via ransomware. So, to summarize, from the network, you have many, many opportunities to catch a threat actor who's trying to extort money out of you via ransomware. And if you're using the right tools, then you have the correct visibility and you have the ability to see things going through the encrypted part of your networks because you can decrypt those traffics, such as MSRPC, you can catch the threat actor right here and ruin his day. So he never actually gets to your domain controller. He never gets to your files, and he never gets to steal your data and encrypt it. Thanks for watching.